last week we actually talked about this project already. So this is a continuation. For the new people here, I'll give a bit of background. So the main purpose is actually just to build a project to learn about validity and learn about rank. So this project came about through the Bucky's workshop. I think Harry has been there as well, and a number of companies there. They always sell out very quickly. Not sell, it's free, but they book up very quickly, like within a few hours. They only have about 25 and so the next morning you check your Meetup and you go, oh crap, all the spots are gone. So what can you do? You go on a waiting list. The issue is that the people who are on the list, they don't want to come in. So they just don't show up. I think Nick has done that a few times. That's what gave me inspiration. How do we penalize the last minute, right? So why don't we use the blockchain? It's quite transparent. You can see all the rules. So the rule that came up was this. So by the way, the GitHub account is if you just Google Meetup Q and my name, you will see this GitHub. And then I'm actively developing that. So I'm always looking for people to join me and help me, especially the front end side. So because we got a limited part, I think maybe 50–60% we're moving on to the front end part. So let's look at the point system. Actually, initially I called it points, but now I convert everything to a token. So this contract is now an ERC20 token. So the rules are that everyone who registers will get 100 tokens to start with. And you can win tokens by doing projects. So if you come to this GitHub account and you do a pull request, you get awarded some points. You can also win points by sharing resources, contributing Telegram, write articles. Basically anything that contributes to the ecosystem should be able to get some tokens. And also with helping these events, the organizers should be awarded, the presenters should be awarded, and also whoever has showed up should get some tokens. On the other side, we also want to penalize people. So the way to do that is we get people to deposit 50 tokens when they come in. So next time when you click book for a Meetup event, you've got to deposit 50 tokens. If you don't show up and you never cancel your spot, we will take all 50 tokens away. Other than that, if you cancel, there's a cancellation schedule. It's a bit like you go to you buy an air ticket. If you cancel 3 months ahead, 6 months ahead, you don't get any penalty. You get all your money back. But if you cancel just before, a few days before, you get a heavy penalty. So it varies by hour. As we approach the Meetup event, we will deduct more points. And to come to the event, you have to join a queue. And the initial queue is based on, it's just based on the time order. So whenever you come in, there's a queue there. So suppose there's only 25 spots. So when it gets filled in, there's no more spots. So if you execute that smart contract, so I want to join now, you just get an error message because there's not enough space. the second way to join that is actually more exciting. That's the auction system. So everyone who cancels their spot at the last minute, they will send their spot to an auction system, where people can use their tokens to bid for the spot. There are different auction systems. So there's auction English auction where the price goes up and up. There's the Dutch auction where the price goes down and down. And there's also the the blind auction. So we might say there's a single spot, and everyone puts some tokens, and then in the last minute we reveal the highest bidder. The highest bidder wins the spot. It's like the house auction. Yeah. So actually I've done this already. So now this contract is ERC20 compliant. So if you don't know, ERC is the protocol on the Ethereum network, and I think 90% of all ICOs are ERC20 token. Any questions? No. There's also the ERC721 token, where so ERC20 is there's a fungible and non-fungible. So fungible means everything can be swapped. You can also divide things up. It's like say your Australian dollar, right? You can divide. I can change my $1 coin with anyone's $1 coin. They won't have any problem with that because a dollar is a dollar. That's what's fungible. There's also non-fungible. For example, your pet. You got a cat, I got a pet. If we swap, are you happy to do that? Maybe not, because each cat is unique.
So CryptoKitties is a non-fungible set of
exactly. Yeah. So each CryptoKitty is unique. It's got unique genes, unique look. So you can't swap it. The other thing that you can't divide it up. So with ERC20, when you deploy that contract, you specify how many decimal places. I think with the NG coin, the Nick deployed forgot to add a decimal place. So everything, the lowest level NG coin is one coin. There's no half a coin or.
So is that good or?
It just means if NG coin becomes as valuable as Bitcoin, you can't use that to transact because it's too expensive.
Okay, we have another coin soon.
Yeah, so with ERC721, there's no concept of dividing it. A cat, you can't put a cat into two houses and then switching. Okay, we also done a voting. So in the voting meetup, every time we go there, we always have pizza. Pizza every single night. Pretty much for 99% of the meetups I go to, they offer pizza. Not very healthy. So the idea is that we give people options, right? So I think blockchain is all about democracy, about giving power back to the people. It's not the organizer deciding what to do. It's about every participant decide what to do collectively. So in this contract, you can see there's a bunch of put options. So you can add put options, you can remove options, you can vote for an option. So that will drive the put choice for the night. So yeah. At the moment, I've got 3 special roles. So one organizer and 2 assistants. They'll be able to create new meetup events. Only 3. Yeah, only 3 people. So So I'll now go into the code. So if you look at this GitHub repo, so if you go into red viewport, so red viewport is the so if you go to triple website, you see a lot of boxes because they come with the pre-packaged program. The viewport is the authentication program where you can link your GitHub or your Facebook, your Google account to an ethereum address. So when you come to the Meetup, you just show your QR code, right? So there will be someone there to scan your QR code, make sure you are registered, you got a ticket to come in. So hopefully eventually the Meetup event will be run by blockchain. So yeah, going to React viewport and contracts folder, these are all the facility codes. So there are two key programs, so Meetup Access Control and Meetup Base. So in this Access Control contract, I've set up three special roles, so organizer and two assistants. And then I've got modifiers where these are the authorization function. So when you run a modifier, you actually run this line of code first before you run the rest. The requirement check the address. So let's make sure that whoever calling this function is indeed the organizer. So for example here, so when I deploy the contract, I'll initially take all three rows, and then I might pass on the organizer row to Nick. So only he can do certain functions. So yeah, only assistants. So either the organizer or the two assistants can do things, and then I can transfer rows. So set up so all I have to do is just set up the assistant contract address to a specified address. Yeah. Message sender. That's the caller of the function. So if you log into dAPP, then you click the website button and say, I want to join the event. You become the message. Your address is the message. There's a global variable that's available throughout. There's quite a few global variables. There's also a message or value where that's how much ether you are sending to the contract. And there's also things like block rate, time, percent. Yeah. So this is setting the address. So for example, I'm setting the assistant one address to be this new address, which I will pass into the function. So when I call the function, you can imagine the front end in the info box. I have to type in the address. So the blockchain then takes that address and then assigns the assistant one address to this new address. So effectively transferring the row. So I've also got pause and not pause. So basically, if something goes wrong, we can pause the code. I copied this code from CryptoKitty. This is CryptoKitty GitHub. So where I think they've done a very good job with this. So if something goes wrong, they can solve the whole thing and save money. Because quite often you can see a lot of smart contracts have bugs in them, and then typically you lose a lot of money. There's so many issues with smart contracts. So yeah, that's this access control contract. Then we go into the base contract. I actually talked through these two solidity contracts last week, but since then I've made a lot of changes. So I'm going to discuss what I've done. So first, you specify the version for solidity, and then you import the other two. So I'm now going to state math. The state math comes from here. So it's formed by a company called Organise. They are a ethereum auditing firm, and they have this library called safe math, where everything is done very carefully. You can multiply, divide, add, and subtract. You might wonder, why do we need to have something so complicated for simple math? The reason is that if you're not careful, you can have a lot of issues. So I was playing with a game called ethereum Ponzi. It's a Ponzi scheme, but what happens is you deposit Ether into the game. Every time a new user deposits money, the earlier people actually get a cut. You might get 10% commission straight away from the new user. So the price can go very quickly. You can earn a lot of money, like people triple their money in a few hours. But when people leave, the price also goes down. The unique thing is that when there's not many people there, when these people actually share a lot of the profits when a new wave of people come in. So when tons of money come in, they actually win lots of money. So I was playing with that, and then suddenly there was one afternoon when I checked the website, it got hacked. So there's some random picture on that, and the contract was hacked. People put out all the money in there. So there were actually quite a few copycats. There are 3 or 4 contracts, exactly the same, different content, same solidity code. So there were people who swiped all the money, and it took about $2 million from all these contracts. So the way they did that was something called underflow. So does anyone know what underflow is? So in solidity we got U int. The U means unsigned number. So it's only 0 positive number. So what if you deduct 1 from 0? Right? What happens? You actually get an enormous number. So what I did was through some mechanism he was able to deduct 1 token from his account with 0 tokens. And he ended up with an astronomical amount of tokens. And then he did a withdrawal. So he took all $2 million through that. And in the space of 20 minutes, wow. Yeah. So the two things are, so first you compile it, then you deploy it, then you can go to you can submit your document and you can verify it. And what that does is it compares the protocol with the bytecode, make sure that it matches. What is it verified? Good practice because it gives people confidence. So they can see what tracking is. Not safe, but if you don't submit, suppose I do an IPO, right? I raised $100 million, and then I don't submit my source code, and then I go away and take all the tokens back. I can do that. I can do the function to move all the tokens to my contract. Yeah. I don't know. You just thought about you can see, you can only execute these functions. So you see you got this function, you can't do anything other than what's already in the contract. So you can't modify the function. You want to connect to yeah, you can describe the different text, but your content is not your code. Yeah, what they did was they caught some function inside the contract, and then they managed to get that from a zero balance account, and turn that into a really astronomical number. No. If you do this, you won't get that problem. So that function so check the right. First, you can only see that number from a bigger number. Right? So if you want to deduct 1 from 0, you can't do that. You have an error. Then yeah, you return that. So basically, OpenDAPP checks everything for math. So we implement that.
So it's saying is that this is pulling that check
Yes.
So that dot check is by person that function. That means you're passing on
it's also
so that's not just to check the balance, right?
no. It's called stub. So stub checked. So you see, instead of doing that, you just call this stub function everywhere. So let's come back to the main contract. So this bit is new. So I've done that last weekend. This is the ERC20 interface. So if you bought any token in the ICO, you're going to the contract, you see this. Right? So these are the functions and events with ERC20. So first, it has to have a function called supply. So we can check how much is supply. You can check balance of a particular address. You can transfer tokens from one person to another. You can call transfer from to. So what this is different to transfer because it allows you to spend other people's money. So for example, so Nick might give me might authorize 1,000 MG coins to me. I can then spend his 1,000 tokens through this transfer from. Whereas if I call transfer, I can only spend my own token. So this is actually quite useful. Approve is authorize other people to spend their tokens. Allowance is to check how much tokens you can spend on people's accounts. And regarding events, so events are very important for front end to pick up. Also for the general blockchain. So when something important happens, for example, CryptoKitty, when a new cat is born, they fire an event called birth event. So everyone can listen to the event and then you can display that on your front end. So you see a new cat popping up. So for us, we might have an event called new Meetup event creation. So when that's done on the website, you can see a new event. So yeah, so there's nothing special about ERC20 token. So if you just implement these functions and events, you will be able to convert your contract to an ERC20 token. So anyone can do that. Okay, so this is the main contract. So Meetup base is I think it's like extend in JavaScript. So it inherits these two other contracts. So this ERC20 is actually a contract interface. Same idea. Using safe math for start. So we're using this open dAPP safe math library. So yeah, see that I got an event. So when we announce a new event, we're going to fire an event there. When we register a new user, we'll fire a new event called user created. So I've covered this last week. I'll go over very quickly. So each Meetup event is a creation time, the start time, the maximum capacity, list of presenters, registration list. So for example, everyone here today would be on this array. This is an array of addresses. So you can imagine everyone. You gotta set up an ethereum account, and when you register your spot, you put your address into this array. And we're also going to use names because that's easier to see. And this is new as well. I've created a user structure. So there's a user creation time, user address, user name, and has to be registered. So this allows people to be deleted. So if there's people who don't behave, we can actually delete them. Yeah, so each ERC20 token needs a name, a symbol, and a decimal. So yeah. So the only So the only standard is here. These are the standards. Yeah. That's it. Yeah. So how to check? It's compatible. Yeah. I think as long as you have these functions, it's compatible. Like if you have, that's why it's transparent. And you can put logic. Yeah. The transfer function just transfer. Yeah. That's why logic is transparent. Everything. So imagine the function called yeah. I think these are all the requirements. Yeah. So what I can do is I can have a function called steal all money, right? So move everyone's token back to my own. So imagine your hard-earned money. I can actually click a button, especially if I don't verify my contract, right? I'm going to click that button and steal all the money. So yeah, decimal, so that's where I think we need to put 0 decimal place. And total supply. Yes. So when you buy an ICO token, right? All you're doing is adding new entry into this mapping. So your ethereum address versus value. So if you own 10 NG coins, you see your address match to 10 is the number 10 in this mapping. So allowance is the thing I talked about where you are allowed to spend other people's money. So you can see that mapping or from address to a new mapping. So this is your address, and this mapping is everyone else. So everyone in the world can have an entry here, and then you got a mapping to the number of tokens you allow them to spend. So yeah. You're allowed to spend multiple people's money. Yeah, that's okay. No. So see, this address can be anyone, and then here you come in again. This address can be anyone. So every person can have an entry here, and then their address is mapped to every single other person. I think it's many to many. But each address is unique. Initial tokens, yes, I just put 100 there. So here I've got the array of meetups. So every event goes into this array. And I also got an array of users. So yeah, I don't think I use these anymore. So I was using these two-way mappings to track the username, but since then I've moved to use this complex structure to track user. Okay, so the next batch is the food vote. So I've got all the food options into this byte 32. So so in Solidity, there are two ways to store string. So you can do string, you can do byte 32. So byte 32 is 32 bytes. That's the maximum space. I think with string, it's actually variable, so you don't know how many bytes it's going to be. So byte 32 seems to work a bit better. Then we got food to vote. So each food option, we're going to track the number of votes, right? Okay, so this is the constructor function, the Meetup base, right? So see, that's the same name as the Meetup base contract. So initially, the owner of the contract takes all 3 rows. I can then transfer the rows to 3 different people. The initial food options are here, so nothing. Yeah, nothing just means if you don't want to have any food for the night. And you got pizza, sushi, salad. So yeah, so you got all these options. Total supply initially is 0. And then we got the create user function. So that's what needs to be done by every single user. So imagine we have this contract set up on the blockchain, and we have this website. So you just have to log on to your MetaMask, and then you click create user. And you'll be able to register your own name. So you have to submit your name, and then the contract will pick up your address, and then create a record in the user's array. Yeah, so there are some checks to make sure that we're not creating the user twice. And then okay, so we're initializing the information. So creation time, address, name, deregister.
Each user is identified by
each user is based on all these 4 different variables. So the
each user has an ID, has a name, username.
Yeah, there's a name and there's an address. There's also user ID, so you actually see here there's a user ID there. So yeah, we got everything.
User ID is different to the address.
Yeah, user ID is like 0, 1, 2, 3, that's an integer. The address is a super long number. So see message.sender again. So that's your address. Okay, so initially we will give you 100 tokens. That's initial token is 100. And the total supply, we add 100 tokens to the total supply. So this concept is actually quite interesting. So the number of tokens is variable. It's not like for Bitcoin you got 21 million. So for this contract, as new users come, we mint tokens on the fly. And then we file an event called user created. We can also deregister. So all we do is we set this value to true. So make sure you're deregistered. Okay, then we've got functions to get the user information. And then we also allow the assistant to add food option. So yeah. So every time we do something like that, we always check we're not adding the same food twice. So we loop through all the entries. If we find a duplicate, we revert. So revert means abolish everything and change back the status. So pretend nothing happened. But you still have to pay gas. So you just wasted 20 cents to do something, but nothing happened. And push is just adding an option to the array. We can also remove food. We can also get winning food. So we loop through all the options and count the number of votes and find the winner. And then we can also clear the votes and start a new round of voting. And then here we create the event. So we got capacity, start time, presenters. So basically we set up everything for a new event. So also we register. I think we create the initial food options. And then there's a bunch of functions where we can get information, get presenters, registration list, blah blah. And what happens with each user is that you have to call the create user function just once, and then you call this join next meetup function if you want to join the event. You don't have to interact with this contract, right? We're gonna build a web front end for that. And then you can also leave. So just say I don't want to come to this event. You can come out as well. Yeah, and then I got all these ERC20 functions. So I've now covered all the Solidity codes. I've done the basic testing as well. So this is done in the Truffle framework. This is the JavaScript code. So you can see I'm doing unit test here, right? So I'm setting up the contract for the test. I create a new contract. I register users. I set the time. I create a meetup event. So I pass on the time. I pass on the number of spots. So yes. So I've done a bunch of unit testing. So the next step is actually to start the React parts. So I'm actually looking for people to help me and work with me on this. The aim is that we build something that we can show people. Then we'll get some opportunities to work on real projects. So if you guys are interested, just go to this GitHub repo, and you can do a pull request. So, so if you're going to, I think these are the JavaScript codes. So app.js. Do we have any front-end developers here? Right. So anyone thinks they might be interested in this? Anyone can commit some time for real? Yes. So I think yeah, I got far enough with Solidity and testing. You know, you might think this testing is boring, right? But what happens is that when you build your front end, all you have to do is to copy these codes into your front end, and that just works. So you can register the user, and you can do all sorts of stuff. So yeah, I think my first step is to design the web page. So does anyone have experience with CSS and how to make the yeah? I've been told that React also has a CSS style with it, right? Yeah. So yeah, so I'm thinking of starting from designing the website and then basically build up all these functionalities first, and then we can expand from there. Yeah, so I think Nick is happy for us to implement this contract for this meetup, right? Or just the front end, right? No. Well, you're happy to use this contract to run this meetup. You know how you're deducting points manually. So we got the Solidity, so we just need the front end. Sorry, I haven't got the points, but I got the other functionality. You. Oh, yeah, whoever is interested. The only thing is with ngCoin, right? With ngCoin, it's on the mainnet, which means everything you do costs like 20 US cents or something. So I wonder, is everyone happy to spend 20 cents for everything to do on this? So who's happy to spend 20 cents? But we can also use Robson, right? Robson Ether is free, so it's on testnet. You get 3 Ether for free from some website. So we can do that as well. Yeah. So that's basically it. Does anyone have any ideas about this project or anything you want to say? Any functionality you want?
Why the contract with the language? We cannot use all in Java. They can call it Java.
Yeah. So with the Ethereum, there are I think 3 or 4 languages, but at the moment the dominant language is called Solidity. Yeah, Solidity. The syntax looks a bit like JavaScript. It's not JavaScript. Yeah, if you do Ethereum smart contract, you have to do that. If you use Neo, you can use Python or something. But I'm told that Neo is still early days, so you can't go wrong with starting from Solidity and Ethereum. If you want to become a Ethereum developer, start from here, and you can actually do other frameworks later on. Anything? Yeah.
Is there anything? Any questions for Professor? No. All right. Thanks. Thanks so much.